So in this video, I'm going to walk through sort of my process for coming up with the design of a state machine for a given problem. So an interesting problem that I ran into recently, and one that I think will make a good example here, is a polling state machine. This is the kind of thing that a lot of applications, web applications, tend to need to do at some point. You've maybe created some sort of resource on like a server, and you need to start like polling for that resource. And at a certain point, you're hoping that resource has been created, and your sort of request to the server polling for that resource will finally resolve to like a successful state where, yes, this resource is created. Here's maybe the ID of the resource. Here's what you're looking for. And then you can sort of move on to the next process. So that's kind of the idea behind a polling state machine. And that is, I think, what we're going to try and design here. So to start, I just want to kind of sketch things out in Excalibur. So I'm going to grab a square and yeah, let's just go like that maybe. And get some text going. And the initial state that I am sort of seeing for myself here is just a polling state. Yeah, maybe that's better. So we'll land in this polling state and we'll just start polling. We'll say like, hey, hit this endpoint, hit this function, whatever it is. Let's think about it as a function. We'll just say like, call this function, see what result you get. And if it comes back successfully, then we go and do one thing. And if it comes back unsuccessfully, then maybe we reschedule ourselves for another polling attempt in, a few seconds, something like that. So even as we start talking about this, we can see that this really lends itself towards a state machine implementation because there's different states, there's different things that we're reacting to. And so I think we're going to find this models really nicely as a state machine. So if the polling comes back successfully, then, or at least what we, and paste that, at least what we would think is successfully, if we receive like an on-done action, which is something that's sort of specific to XState, then we'll want to like verify, we'll just have like a verify state. And so that's one place we can end up from the polling state. We can also end up, if it didn't hit the on done action, if instead it hit like an on error, if the polling failed, if it didn't find the resource, then we are in a sort of like not a failed state. We expect to end up there, but we need to try and schedule again. So we'll call this schedule again. Actually, all these texts are a little too big. Medium, there we go. So we'll end up in like a schedule again state. And so what that can do is it can try and schedule us for another round of polling, which would be nice. But we don't want our machine to just poll forever. That could have some, adverse consequences if we hit our server too much, or if we just leave the user seeing like a UI state that's just spinning forever. That's not good. So I also want the schedule again state to potentially put us sort of down here in like an expired, like polling expired perhaps. So that way if, maybe we've polled 5 times and that's sort of what we've decided our limit should be. Any more than 5 times, well, we don't expect we're going to have a success after that. So let's stop polling. So that's what the polling expired state will be. So this will be one of our final states. So jumping back again to the verify, if we get here and we say, hey, even though you came back as undone, it doesn't actually look like you retrieved a value we were looking for. So let's just schedule you again. That's an option for us. But the real thing we're looking for is we found the thing. This is like our happy path here. we found what we were looking for. We're in like a finished or, resource found kind of state. And this is the final state that we kind of hope to end up in. So this all looks good. But I think when I start thinking about modeling things in XState, especially something like this where it's like, oh, you're polling, but you're immediately polling and you're in this sort of process that's going. I like to step out a layer even and maybe think about like when I first land on the page or wherever it is where the state machine gets instantiated, gets interpreted. As soon as the state machine gets interpreted, maybe I don't want to immediately start polling. Maybe I want to have some control over that so I can actually wait for some sort of like event or action that happens that will then trigger the polling. So what I can do is I can have an inactive state and then a corresponding active state. And so you can go from active to inactive, or inactive to active, and you can go from active to inactive. And then this is where I feel like XState really shines, is that I can do some nesting to sort of help, to really help model what I'm trying to do here. So I want to think of like everything as like sitting inside of, trying to grab this and everything's getting in my way here. Slide that over. There we go. So I love the concept of nesting in XState because what it allows me to do is say like, well, I'm either inactive and no polling should happen, or I'm active and some polling should be happening. And rather than having those just be at the same level of hierarchy as the rest of the polling machine, we can actually think of those as something that like sits above the concept of the polling machine. And so the polling machine or these polling states are nested in our substates of the active state. So when certain events come in, those events, if we're in the active state, won't start any polling. If we have some sort of schedule another polling event come in, that's not going to do anything if we're in the inactive state. So I like being able to separate these two things, inactive and active, as a way of, thinking about the different modalities of the machine we're trying to create. So with all of that in place, I feel like we're ready to maybe dive back into the code and try and sketch this thing out. So let's go here. So I've got a polling machine, but really what I have inside of here is a minimal little counting machine. And so I want to use some of the pieces that are in here. The ID is good. Every machine needs an initial state. So I'm gonna, I guess, have inactive be my initial state. We'll have to work on the context. I'm not totally sure what that's gonna look like yet, but first let's talk about our states. So we'll have an inactive state, and that's going to have some stuff in it. And then we'll have an active state. And so I guess how is it that we get from inactive to active? Well, we're going to have some sort of thing that triggers it, and I guess we'll just call it a toggle event. And that's just going to have a target of active, and that'll send us over here. And I think similarly, I don't know if we're going to use this here, but I suppose you could toggle back to the inactive state. Well, if I don't know if we're going to use it, then let's not. Let's call this something else then. Like activate. And then let's not have a toggle action here, because I don't want my machine to have sort of anticipatory transitions or states or anything like that. I want to add exactly what I need at the time I need it, and that way we can keep the machine as simple as possible. Keep the machine having as few states and transitions as possible. They're finite state machines, so the states we're going to have are finite, but finite can mean 1,000 and finite can mean 10. And so if I can get a machine working with 10 states rather than 1,000, I think that's a win. And so err on the side of fewer. So let's see, we've got activate. That's going to send us to active. And then we're going to have to maybe do something here at some point. Not sure yet. But then we can also nest some states inside active. And I think this feature of state machines and of XState is really an underutilized way of modeling a problem. And I think it's where, especially in UI programming, the way you can start to take sort of the different Booleans that UI ends up with and put them into a more cohesive form is with this nesting with substates and all that. So I think that's why I get excited about the idea of nesting these things. So yeah, what are we going to have here? We've got a picture. So polling, let's start there. So we'll start with a polling state. And I think our polling state is just going to call some sort of promise. It's going to invoke a promise. So we can see invoke callbacks. XState, I think, is what invoked services, and then an invoke service, invoking promises, yeah. So we can see there's a loading state, which is kind of like our polling state. And the thing it does, as soon as you enter into this state, this invoke gets called. And what does it do? It looks for the source and calls that thing. So we'll need an invoke, may not need an ID, but we'll have a source, an undone, and an error. So let's go ahead and try that. Invoke source, which is retrieve resource, which is sort of the action our polling machine is going to do on each poll. And then there's an undone. So this is the function that gets called if retrieve resource comes back successfully, if the promise resolves rather than rejects. And we also have on error, which is what gets called if the promise rejects instead of resolves. And what's it saying about invoke? I'm not sure. We can hold off on that a moment. I think state invoke. Yeah, I think we're okay here. Cool. So this is what our machine looks like so far. And then we have, let's see, we have verify schedule again. Let's create these two final states, resource found, polling expired. Because those are where we ultimately want to end up. Oops, wrong layer of nesting. Say resource found. So we're just indicating to XState that this is one of our final states. And then polling expired. This is also a final state. And I think if we get here, we want to have some sort of action that we call. So report success or something like that. And here we'll say report failure. this is more like these things, we don't know if the final shape of the machine will necessarily need these exactly, but at least as I'm building this thing out, I want to have some indicators of where we ended up and how the health of the machine is going. So we can even go down here and define an actions object in our machine options, which will have report success, and that can, log out to the console saying success. And then similarly, we can have report failure, report expired maybe. And we can say console.log expired. And so then I'll have to update the name here, report expired, because these correspond one-to-one here and here. So those are our final states. It's not assignable to type. Let me make sure that's a XState final state. Maybe it's type final. Type final, whoops, okay. So that was a helpful error. This is also why I think it's pretty necessary to write XState machines with the help of TypeScript, because if you're just writing JavaScript, a lot of this stuff is gonna fly under the radar until execution time, and that can be tricky to debug. So as much as the TypeScript compiler can help us, we want to let it. Okay, so what piece of this do I want to look at next? We invoke this thing, on done. What do we want to do here? Well, I guess we need these next two states if we're going to figure out what to do here. So we have verify and schedule again. So we'll do verify. And so in this verify state, we'll transition here, and I think we might just have some sort of like always block. Like as soon as you go in here, this is what you do. So like you could say, you always transition to target resource found. I'm gonna make this a string identifier. Could always transition to target resource found. You could even say condition resource is verified, something like that. And then we could come into our machine options and define something that verifies the resource. So if we did have this condition and the resource wasn't verified, well, we'd need somewhere else to transition if that condition fails. So we could say target schedule next poll. So maybe our API responded with the 200, but it didn't actually get anything. That would be sort of a false positive, I suppose, and so we'd want to schedule another poll. So our other state then is schedule next poll. And this one, I think the way I want to do this one is using something that's kind of cool. Delayed transitions, delayed events. So the way these work is you can, inside of a state, define an after block, which is kind of like the always block, but it takes these key value pairs where the key is a number of milliseconds, and the value of that key value pair is then a transition. So we could say So I guess my thinking here is if we transition to the schedule next poll state and we're going to like schedule the next polling event, but we don't want to do it immediately. We want to like wait a little bit so that we're not just hitting our server over and over again. And we want to give time for whatever server process is happening that is creating our resource. We want to give it a little time. So the polling is going to wait a second or two and then schedule itself again. So we can represent that with this after, and that will look like this. So we'll say after 2000 target, and we'll just put ourselves back in the polling. Yeah, I think that works. But at a certain point, we need to expire ourselves. So we don't want to go forever. So what's the condition of expiring ourselves? I suppose, I think maybe I said earlier, like if it happens like 5 or more times, like if you're making 5 or more polling requests, probably that's too many. I think it really depends on the particular application context, but we can assume 5 for this example. So that implies that we're going to have to keep a count. So I think this brings us back up to our polling context. So this count was for the counter machine. I want to do something similar, like a polling count. That way I can just keep track of how many polling requests we've made. So I'll say polling. I think we need an entry event. So as soon as we get in here, we assign count with an incremented value of count. And so we do that with the assign action, which comes from XState library. So you should never try and make like inline updates to the context. You should always use the assign action to update the context. Let XState take care of keeping those things consistent for us and not try and implement that ourselves in the midst of like the React render cycle or whatever. So what is it complaining about here? There's no call signature. Oh, because entry. Oh, whoops. I don't want to put an object here. I just want to have it be the single action. And this isn't count, this is polling count. Let's get more help from TypeScript. It's still unhappy about that. Call it polling count, context, on type unknown. So why does it think context is unknown? That's interesting. I'm gonna ignore that for a moment because I wonder if something else is tripping it up. I don't totally believe that. I wonder if I'm missing some other piece of syntax. Polling count, inactive. Well, I know one thing that I'm missing. The top of the hierarchy of our state machine has the initial state of inactive. So as soon as this machine starts up, we'll be in the inactive state. Well, if we activate, then we transition to the active state, but we don't tell it anything about what substate it should be in initially. So we need to give this an initial as well, so that when you end up in active, you tell it that we're initially in the polling state. Context polling +1. This error here is really bugging me because it does not seem like that should be an issue. Unexpected token. Oh, maybe this is more the issue. Unexpected token on... Oh, yep, right there, sure enough. Missing that comma. The other commas I'm missing. No, I got one there. Seems like the rest of initial on unexpected token, line 38. Always. Is that not how always wants to? Oh, always wants an array. Just listen to the compiler. I'm trying to assume I had everything right, and the compiler is telling me exactly what line the issue was on. Okay. And it's still mad about this invoke, but I think we'll get there. Okay, so where were we? We wanted to keep track of a count. So each time we end up in the polling state, we know polling, a request to our retriever resource is going to get triggered. And so the entry into here, we want to increment the count. So that way in our schedule next poll, we can check if this thing is ever expired. So we'll say transition back to polling if the condition is met, and the condition I think is if context.polling count is less than or equal to 5, perhaps. Yeah. So after 2000, do that. Otherwise, is there a way for us to do that if the condition's true? Otherwise, we want to do a different kind of, we want to transition to a different place. This is what I'm looking for, conditional. So we nest those in an array. Okay, cool. So similar to the always, we'll put an array here. Nope, not quite. We'll put it here. So we'll say after 2000, try and do this target transition. Otherwise, if the condition isn't met, then go to the next one. And so the next one will be expired. What do we call that? Polling expired. So I think this is really pretty clever, the way we can use these after delays, where we can say like, hey, wait 2000 milliseconds, so 2 seconds, and then try and do this transition. But if this condition isn't met, well then fall through to the next transition. You even have multiple of these. We could put another condition on this one and then have like a third fall through as well. There's also, and I'm not going to get into this here, but there's ways to cancel something. So if we're, waiting 2 seconds, but after a second we know something else that tells us we want to transition somewhere else, we can cancel this one. So that's kind of cool. Yeah, we have a similar functionality with the always. Always transition here if this thing's met. Otherwise, transition here. So now that we have those pieces in place, I think we can, we got to close that. There we go. Now we can kind of figure out what we want to do with these on done and on errors. So on done, I think we get a, let's go back to services. No. Yeah, undone. We can give it a target. We can give it actions. Yeah, so I think we just want to give it a target. So undone, our target is going to be verify. On error, target is going to be schedule next poll. So if it feels like, well, why do we have this intermediate verify state? I mean, beyond just like wanting to do the verification, like why can't we do that in the undone? And hey, maybe there's a way to do that. I think it's a little cleaner to just let the undone transition to here and let the verify sort of be a standalone place where this concern can be managed without mucking up the logic of the invoke any further. So we do need resources verified. I think you can imagine that could be a lot of different things. And resource is verified. And I think for the sake of this example, I'm not going to do anything fancy in here. You're going to have access to the context, and so you could dig into that and do something with it. I'm just going to return true, and that way I can say like, hey, it's always verified, and we can move on. Yeah, no, this is good. The only other thing I was thinking about is, so we are trying to retrieve something. So we're going to have some resource that we are retrieving. So, and we're going to want to put that in the context. So I'm going to just call that retrieved value, I guess. And so that can either be a string or undefined, I suppose. Or it could be, I guess, an optional string. Yeah, something like that. So I think our machine's really coming together here. We've got report expired, report success, resources verified. Is there anything else that needs to, this condition's in line, resources verified. Yeah, that's nice. We can see these two different ways of defining a conditional. Oh, since this is a conditional, I'm really glad I was trying to make that point because this doesn't belong in here. I don't believe. I think it belongs in like cond conditional, something like that. Guarded transitions. Guards, okay. That's what I'm looking for. So the machine options, they can take action, services, a few other things. And if we want to define an identifier for a condition that is then showing up in our machine options, we put it inside the guards object. So guards, like that. And I guess we need our closing here. I think that should be all good then. It's got actions, guards. Wonderful. And honestly, we should probably define retrieve resource. I think I'm going to pass that in the interpretation step. But I think if someone's going to come in and try and understand what's going on in this machine, I do want to have this here where I say something along the lines of this needs to, I don't know, must be implemented, something like that. Because then as I'm scanning through this machine, seeing what are the machine options, I'm like, oh, there's a retrieve resource thing that is not implemented for us. That's something that a consumer of the machine can provide. And what's it? Underlining it about. Oh, right. It needs to be a promise. Okay. Cool. So I like how this is coming together. I think what we can do is try and wire this up to our React context, which is this app here. I've already defined a polling action, like the function that should get called by our polling machine. And then I've also got a function that will sort of alert us on success. So we'll pass that in as like the success function. And here's where we're interpreting the machine with the use machine call. So this is where I can pass in the sort of overriding retrieve resource function, which is going to be this polling function. So this one that I defined here is going to override this one. And then the consume polled value, I guess that's something we want called in our report success. Yeah, maybe that's what we want report success to be. So I can override that as well then. I can go into actions, report success, and define that as, what was this value? Consume polled value. Okay, so we see that aligning nicely. And so, yeah, what about this thing? It's saying, are we actively polling? And that's coming from here, the current state. So the state we get from use machine, if that matches active. So that aligns nicely. The active is the state we care about, then we're actively polling. Actually, that's not, I want to say active dot polling, or maybe, well, that's interesting. So if we're expired or if resource is found, I think we're not actively polling. But if it's schedule next poll, I think we are actively polling. So I think if we're in the polling state or the schedule next poll, then we're actively polling. So it's one or the other of those. So if active.polling or current.matches active schedule next poll, then we are actively polling, in which case we can show the thinking emoji instead of the sleeping emoji. And now the only other piece of this is, how do we start polling? Well, we have this button that will trigger it. Maybe the page loads, you have a use effect, and that's when you start polling. Maybe a user clicks on something and that's when you start polling. This is sort of where a particular scenario is going to really determine what comes into play here. Just for the purpose of this example, I'm going to have us on a button click, we will, activate our polling. Yeah, so let's try that. Start polling, we're thinking. And it just occurred to me, I'm going to refresh this because it just occurred to me that we don't have anything really reporting our progress. So I'm curious, on entry, maybe can we have it do multiple things on entry just in an array like this? I think we might. wonder if this gets context. Polling number context dot polling count. So that might be a way to just indicate in the console if we're making any progress. Okay, let's start polling. Polling 1, polling 2, 3. Object, object. Okay, so this is mostly working at this point. This didn't quite, this piece of it didn't quite work. But you saw that we pulled 4 and then it went to, I guess, pulled a 5th time, and it no longer met our polling count condition, and so then it expired. So why did it report success? No, I think it was report expired. Or no, I think it succeeded. Yeah, because we only got to the 4th poll, and then we saw an alert, and the only place we have an alert is right here. So we had success, but the value rendered as object object. So, oh, I see. We're going to have to treat this like context. And then we'll do context dot retrieved value. Retrieved value. Now let's try that again. Undefined. That's interesting. So the way I designed this polling function is it's random. It's going to grab a random value starting at 3, but increasing. And so I think when it first starts, it has no chance of finding a value greater than or equal to 4. But as it continues to count up, there's more of a chance of it finding a value that's greater or equal to 4. And so if it has that success, then it'll resolve to this. So I think okay, I know why that's undefined. So I think it's not getting set. Verify on done. I think on done needs to do something because, yeah, here we're just resolving the value. So on done is going to need an action as well, I guess. Let's actually take a look at how it's done in here. So invoke services, on done. So this on done has a target, but it also has an assign action. Yeah, that's what we're looking for. So it's event.data. Okay. So we'll do something similar to that, where I will say actions, we'll do an assign, and the value we want to assign is retrieved value. And off of the event, we'll grab event.data. We'll have to see what event.data is. We might do something like this. Just so we can log it out. Then we'll return event.data as well. Cool. So if I start polling, every 2 seconds it ticks. Success on try 6. That's interesting. That makes me think. Okay, so we got the data returning appropriately, the values getting assigned to the retrieve value. So that feels good. But success on try 6 makes me think that we're not actually expiring out of this thing. So when our thing ends up in schedule next poll, it's saying you can go to a target of polling if the polling count is less than or equal to 5. Would that work? Maybe it needs to just be less than 5. Maybe less than or equal to 5 would result in a count of 6. Yeah, it would, because if you're at 5 and you schedule another polling and you come in here, then you'll be on your 6th time, where this value will then it gets incremented from 5 to 6, and then okay. So yeah, I guess less than 5 is what we're looking for in terms of staying true to. Let's only do this 5 times at most. So let that run again. I kind of want to see it fail. That would be helpful to see it fail. Oh, good. So that expired. So that's what we wanted to see. And yeah, this is interesting. So I didn't model for sort of what if we want to start the polling again. And I think that's fine because I do want these to be final states, but if we want to continue to experiment with this, we have to refresh the page and then we can start polling. There, we found it on try 2. So that's cool. I think that's probably a good place to stop with this example and this machine. So I guess if I were to just highlight the things that I thought were most interesting about all of this, I guess first off, just being able to step back from the code and think about how this looks just with boxes and arrows was really helpful. And I think that's a huge part of the value proposition of XState and state machines and state charts in general is as much as it is a coding tool, it is a design tool and a thinking tool. And so for us to be able to step out and think about the problem and model it just on paper this way before even getting to the code, I think it gives us a better chance of ending up at a solution that we can feel good about, a solution that is well-reasoned. Certainly, all of our solutions are going to need tweaking and further work and are going to have to evolve along with user needs, but to even just have that foundation in what we're building, I think is exciting. So that's one piece of it, is just thinking, design, stepping back from the machine. The nested states, I think, are a really powerful concept, and I definitely encourage you to keep those in mind as you're thinking about how you want to design a solution to a particular problem. Invoked all kinds of things. Invoke promises, invoke services. That's a really powerful way to do practical things in XState. So keep an eye on those. Look for a chance to use those to experiment with them. And I guess the last piece is just the always and the after. The after allows you to apply some sort of delay. The always allows you to just do immediate transitions, but with the conditionals allows you to kind of add some really useful logic in. So these, are the things I wanted to highlight. My approach to designing state machines with XState has been evolving, and it's going to continue to evolve, but this is kind of where I'm at right now. And I am interested to hear how you think about designing XState machines, if you would have approached designing this polling machine differently. I'm sure there are dozens of ways to do it. That's part of what makes XState so powerful. Drop a comment below or hit me up on Twitter as well. And if you enjoyed this video, if you want to see more stuff like this, please hit the like button, subscribe to get more great XState content, more web dev content in general, and I will see you at the next one.